Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, April 6th. Looking at significant wave heights for the North Pacific Ocean, we see a gale north of Hawaii producing 26-foot seas aimed more or less south, more southeast than south, and also another gale developing over the North Dateline region, it too with about 25-foot seas aimed off to the east. This is likely the last hurrah for winter in the North Pacific. As usual, we start this week's tour looking at jetstream level winds. These winds up about 30,000 feet help support the formation of gales, and when those gales form, help direct their track. We're looking for troughs. That is a dip in the jet, just like that right there. The jet dipping south some, being fed by 140 knot winds. That helps create a counterclockwise circulation aloft and down at the surface. And of course, that's the hallmark of low pressure. And low pressure generates wind. Wind generates seas. Seas, as they radiate away from the fetch area, produces swell. And swell, when it arrives at your beach, produces surf. So we have a trough over what we call the North Dateline region. There's the dateline. There's the Aleutians. The intersection of the two is the North Dateline region, so it's approaching that area. We also have a very steep, sort of almost cut-off trough developing just northeast of Hawaii, also being fed by about 130 knot winds. That's also helping to support low-pressure development there. But then we have this big ridge off on the other side of that trough that's supporting high pressure in this area and no support for gale development. Anyway, let's sort of roll this out. And as you can see as we move into Monday, the trough over the dateline continues, as does the trough northeast of Hawaii, but that one northeast of Hawaii starts losing energy, looking less organized, and then tries to sort of rejuvenate a little come Tuesday, while the North Dateline gale starts, or their trough starts fading out, and probably not a whole lot of support for gale development from anything. As we get into Wednesday, you see the jet pretty much aligned just straight to the east here on about the 43 north latitude, but it looks like a trough is trying to develop here come Wednesday. Again, just over the dateline, south of the North Dateline region, and kind of organizes some into Thursday, being fed by, what's that, about 160 knot winds, we'll say, offering support for gale development, and continuing into Friday and Saturday, moving into the northwestern Gulf and fading out. At that time, then the jet starts looking very weak. We're at 180 hours out. The jet running still right around the 43 north latitude line, pushing up into British Columbia, but weak. No troughs really indicated. Not a lot of support for gale development. It is May. We'll be into the middle of May by then. So this is pretty much typical for this time of year. Let's go take a quick look down at the surface. So here we are, surface level pressure, surface level winds, and as expected, there, well, we have a 1,000, maybe a 998 millibar low here in the Gulf of Alaska, generating 40 knot winds out of the northeast. That's probably generating a little bit of swell pushing south towards Hawaii, and not really at the U.S. West Coast. It's really pushing down in this direction, not a whole lot there. Then the North Dateline system also generating 40 knot northwest winds. That also is targeting Hawaii and also the U.S. West Coast, but from a long ways away. So we move into, say Monday morning, the gale north of Hawaii pretty much fades out. Whatever it's going to do, it will have done by then. North Dateline gale, in the meantime, sort of wakes up, rejuvenates a tiny little patch of 45 knot winds, mainly 40 knot winds, south of the Aleutians, aimed east. Oh, there we go. 45 knot winds, 18Z on Monday. And then, as we get into Monday night, into Tuesday, it starts ramping down, 30 knot winds, and fading out. Now, there's this other little patch of low pressure wrapping around under that, previously forecast to kind of wake up Wednesday into Thursday in the northwestern Gulf, but the latest runs of the models not so supportive of really any fetch of interest. 25 knot winds here in the just barely in the northwestern Gulf, and that's not enough given the travel distance to either the U.S. West Coast or Hawaii. Instead, local wind swell looks like the name of the game for California, but we'll get into that in a minute. Then things quiet down. Supposedly some tropical system developing. Don't believe it. Seems a bit premature. As we get into Saturday, fetch in the Pacific really settles down considerably, and it's all downhill from there, the focus likely turning to the South Pacific. And then finally, what are the effects of those winds on the ocean surface? Well, we can see that right now. We saw the seas. What is that? 26 feet north of Hawaii. Another area of, what about is about 20, 24, 25-foot seas on the North Dateline region. There we go. Seas to 20, barely 28 feet as about right now north of Hawaii, fading out as we get into Monday. And meantime, the North Dateline gale develops 20, 22, 20, let's say 25-foot seas, just sort of looking, even 26-foot seas there later this evening, Sunday evening, and then up to 30-foot seas as we get into Monday. That's good for maybe 16-second period swell radiating towards targets in this direction. But given the rather small coverage of those 30-foot seas and the rather long travel distance, just eyeballing about 2,200 nautical miles, whatever swell you get, it's going to be small, 3 feet, 16 seconds, something like that at best. Probably more in the 15-second period range. Anyway, that system pushes east into the northwestern Gulf, fades out with seas dropping from 20 feet by late Tuesday. And then here's this next system that we were hoping kind of would wake up, but you see, we'll just go back here. These seas, 20-foot seas, 22-foot seas, are all aimed to the north from south winds. The core of the low is over here somewhere, and just really nothing expected. You can see wind swell developing along the California coast for Friday and Saturday. Then that fades out, and then things get very quiet indeed. Let's go take a quick look to the South Pacific. A little bit more action forecast there. So here we are, South Pacific, right here. First gale we're interested in, 20, 22, 24, 25-foot seas. Pretty well to the north. Here's 40 south. The further north these systems go, the less travel distance to the U.S. West Coast, less swell decay, and so lesser seas can actually generate meaningful swell. This is good enough for maybe 14, 15-second period swell. But as we get into Monday, seas are supposed to build to nearly 30 feet over a tiny little area here. And again, this is at 40 south. That's not a bad location. And California is at about, let's say, 120. So almost due south of California. And then that system starts fading out as we get into Monday. Now we're going to go back just a little bit. Right here we are right now, New Zealand. Swell, or a system, gale, developing 37-foot seas. If you look at the Great Circle Pass, these seas are on the route to Northern California and to Southern California. Not quite to Hawaii yet, but certainly by there, by Sunday night into Monday, yes, but notice this system fading rather quick. But this is really just a precursor, a warm-up swell, a teaser swell. It will rough up the ocean surface, allowing the next gale traveling in behind to get good traction on the ocean surface. And we see 52-foot seas as we get into Monday night. Now that's all shadowed. Certainly not for Fiji, and maybe some backdoor energy for Hawaii up the Tasman Sea. But then as we get into 06Z on Tuesday, we have 58-foot seas just barely in the swell window for Southern California, and then 56-foot seas Tuesday morning in the swell window for both North and South California, but not for Hawaii. And then eventually by 18Z on Tuesday, 54-foot seas targeting Hawaii, U.S. West Coast, and Tahiti. Swell, long period swell, certainly possible from this system. It's not huge, but still, swell from the favored New Zealand corridor is good any way you can get it. And so that system fades out as we get into Wednesday. Now, the models were suggesting, and still are suggesting, a series of other gales developing starting late in the week under New Zealand, a tiny little system producing 40-foot seas, and then this other system as well, not as defined as earlier. And then there was supposed to be, early versions of the models had a very strong system again developing over in this area, but now not looking quite as impressive. Still 37-foot seas and aimed reasonably well to the north as we get into Sunday. And we got one more frame or so there. And there we go. 42-foot seas, 43-foot seas in the California swell window, unshadowed from Tahiti. Of course, that's a week out. Hard to believe, but certainly swell radiating north if it does develop for the whole location. So the good news is South Pacific appears to be waking up, and it's the Southwest Pacific. That's good news. That will pick up the slack from whatever isn't happening in the North Pacific. And then we're going to focus real quick here along California. Winds. We're looking for potential for wind swell development with low pressure here sweeping through the Gulf. It takes high pressure to generate winds. Typically you get high pressure, clockwise circulation off California. Low pressure, heat pressure inland. That creates a gradient that will create north winds. We're not seeing so much of that right here in this frame, but as we get, here you go, here comes your high pressure, 1028 millibar high, generating north, or we'll call it east-northeast winds into the Hawaiian Islands, 15 knots. That's good for wind swell there. And then as that high starts impacting California, same deal. You start getting 20-knot north winds, and then building as we get into Thursday night, Friday, 30 to 35-knot winds over the North California coast, building nicely into Friday. Now, what we really want is for an eddy flow to develop. So you have strong north winds off North California, but the fetch sort of pulls away from the central California coast. You get this south flow pushing up, and that can make for cleaner. There we go. Look at that. Right there. Broad area, 35-knot north winds Friday night, generating wind swell pushing down the central California coast. And then that starts fading, and there you go. There's your low over the coast. That'll create an eddy flow for Saturday. So larger wind swell with cleaner conditions at select locations. And then that all starts fading out on Sunday. And then we're back to a lighter pattern, but more high pressure building off the coast, likely building more wind swell at select locations. All right, let's take a look long term. What's going on more than a week out? Maybe the next couple weeks, maybe even the next couple months. So we'll take a look first at the MJO. That not so much helps dictate the weather pattern this time of year, but can have an influence if you get a strong active phase of the MJO. Of course, let's go see what's going on with La Nina, El Nino, and see if there are any developments in that regard. So first off, we start looking for signs of the active phase of the MJO. We look at winds across the equatorial Pacific, East Pacific here, West Pacific here, New Guinea there. We see east winds. This is from the TAO buoy array, series of buoys strung across the equator used for monitoring El Nino and La Nina. We see the arrows, strong east winds, trades, typical for this time of year for the most part. But notice as you get into the West Pacific, they get much calmer, if not reverse direction a little bit. Okay? Looking here, anomalies, differences from normal for this time of year. Yeah, these east winds are pretty much typical, normal. Notice there's no real arrows going any one way or the other. But as we get into the West Pacific, we see a couple little signs of west anomalies. Maybe that's indicative of the active phase of the MJO, or it could just be normal. Pretty slack wind pattern here in the West Pacific, though. And we're particularly interested in what we call the Kelvin wave generation area. There's New Guinea there. There's the Philippines. There's South America there. So we're on the equator from 170 west, 5 degrees north and south of the equator, from New Guinea, 135 east to about 170 west. A little box right in there. And you see this. These oranges and the arrows pointing from the west, these are westerly wind anomalies, differences from normal for this time of year, suggestive of the active phase of the MJO. That was on April 30th, and you can just sort of scroll down here and look and see that's been a pretty consistent pattern at least through May 4th. Let's go see what's going on now. So here's another chart. The date line is right here. This is the entire planet on one chart. Kelvin wave generation area basically between these two tick marks. Okay, but we're going back to April 6th. Oranges and yellows suggest westerly anomalies. Blues suggest easterly anomalies. If we want the active phase of the MJO, which we do, then we want westerly anomalies. So we go down here between these two tick marks and see, oh, yep, sure enough, starting late April, we had westerly anomalies, and they continued for the past couple of days through May 6th. They're still in control, filling the Kelvin wave generation area. But here we go. As we get into about the 8th of May, they're to start dying out. And then we get easterly anomalies building in the heart of the Kelvin wave generation area. That is not favorable for helping to feed the jet stream and helping to build to feed storm development, mainly in the northern hemisphere, mainly in the fall and winter months. But if you get a strong enough active phase in the summer, it too can affect the southern hemisphere, but the correlation is not as strong. We look for other signs of the active phase of the MJO, looking at outgoing long-wave radiation charts. That is, what we would want to see is the color blue here, meaning less sunlight reflectivity off the ocean surface over the Kelvin wave generation area. Again, there's New Guinea, here's the equator. And what we see is nothing, meaning no sign of the MJO, and for the next 15 days, the statistical model, the active phase of the MJO is not to develop. Now we go down and look at the dynamic model, the GEFS model, and it says, yeah, starting out the same, basically no MJO signal, but oranges, yellows showing up, filling the Kelvin wave generation area. Those are positive numbers, meaning more sunlight reflectivity, meaning high pressure, meaning the inactive phase of the MJO. So sort of a split deal here, either no MJO or the inactive phase of the MJO setting up 15 days out. So no real support for storm development in the northern hemisphere for the next 2 weeks, at least per this model. Looking at phase diagram charts, so assume this circle you're looking down on the North Pole, and the MJO, active phase and inactive phase, moves from west to east from the Indian Ocean, over the maritime continent, things like Bali, over the date line, and across the Pacific, under the United States, on the equator only, across the Atlantic, across North Africa, back to the Indian Ocean. Round and round she goes. The heavy dot is where the active phase of the MJO is, so it's in the Atlantic right now. So one can assume on the other side of the Earth, in the, let's say roughly the maritime continent, that's where the inactive phase of the MJO is. And the active phase, so if the dot were inside the circle, it's very weak, but it's just a little bit outside the circle. So weak to maybe building. The green line is the forecast for the active phase, position of the active phase and strength of the active phase of the MJO, moving into the Indian Ocean 2 weeks out, and then just sort of sitting there. That per the ECMF model. GEFS says the same thing. So basically, in the Pacific, over in here, no sign of the active phase for the next 2 weeks. That's not favorable for storm development. And then looking at the upper level models, okay? If you see greens, that's the areas favorable for precipitation. Right now, we see what looks to be, and this model runs about a week ahead of what's really going on down at the surface. This is up at jetstream level. We see what appears to be the last bits of the active phase of the MJO moving into Central America. This is the equator right here. Right here. And that's to be moving off into the Atlantic. Inactive phase of the MJO per this model setting up around May 11th, traversing the Pacific, moving into Central America around the 5th of June. But also here we see the greens, the active phase of the MJO, areas favorable for precipitation, moving into the West Pacific, late May, and then those two making their trip across the Pacific, equatorial Pacific, into about June 15th. In fact, we read a paper or saw a post somewhere that says the average periodicity for the MJO has been 41 days, and it's been lock solid, making it across the Pacific. So 41-day trip, a little over a month. What was that, 5 weeks? That's about normal. Active phase of the MJO, followed by another week inactive phase of the MJO as we get into mid-June. Then our favorite trusty CFS model, good for monitoring long-term trends. Now this chart, again, whole world on one chart. Kelvin wave generation area between 135 east and 170. So we're basically going up the chart this way. Past activity here. Large active phase of the MJO back in February created actually a significant Kelvin wave. We'll get into that in a minute. Right here is where we are today. See westerly anomalies in the Kelvin wave generation area. Little pocket here of easterly anomalies forecast a couple days out. That's probably those easterly anomalies we saw on a previous chart. But then as you just sort of wander up here and you look through the Kelvin wave generation area, the pattern generally looks like westerly anomalies building in control. There's a method to our discussion here. So let's overlay the MJO first. There's the active phase of the MJO. Supposedly we're in it right now, but it's supposed to fade out in, what's that, about a week, let's say. And then a week inactive phase, very weak. But notice, Still, westerly anomalies, these yellows, weak westerly to neutral anomalies, little shades of easterly anomalies, but mainly westerly anomalies in the Kelvin wave generation area, even through this inactive phase of the MJO. Then we get into a strong active phase, or at least a moderate active phase. So we get into the first week of June, and that goes the whole way through July. And then, even after that, another inactive phase of the MJO over the Kelvin wave generation area, but westerly anomalies continuing. So what's going on? Persistent westerly anomalies. What is the cause of that? Well, we've been talking about this in the past. We overlay the low-pass filter, and here's the key. Kelvin wave generation area between 135 and about 170 west, and you just go right up here, and look at that. You see that solid line? That now, this is what we call the area of bias towards low pressure that is filling the Kelvin wave officially as of today. This is good news. This is also tied with the demise of La Nina. The dotted line here is the bias in favor of high pressure. That now moves into the eastern Pacific, away from the Kelvin wave generation area, and is to hold as we get into the early part of fall. But notice 1, 2, 3 isobars as we get into July, starting to build over the Kelvin wave generation area. This means that the bias towards low pressure over the Kelvin wave generation area is only to be building through the summer and presumably into the fall. We're not talking El Nino, but what we are talking is return of at least a normal pressure pattern, and a pattern that will be more favorable towards storm development as we get our way into the fall. This is good news. So now we move away from the MJO discussion. We kind of get a sense of what's going on, and let's talk El Nino, La Nina, what's going on in the ocean, because that is one of the better ways. I mean, ultimately, that determines La Nina or El Nino is surface water temperatures along the equatorial Pacific east of the Kelvin wave generation area. So, subsurface temperature profiles, East Pacific here, West Pacific here. This data, again, from the TAO buoy array. The anchor lines on the TAO buoys on the equator. You can see the little X's there. That's where the data comes from. Then you use that and a model to sort of fill in the gaps in between. We see warm water. Of course, it's been here in the West Pacific, but the 28-degree isotherm for a year has been locked like a brick wall on the dateline, and just this week it broke free and now is starting to push to the east to 170, almost to 169 west. The little finger here moving to 167. This suggests that warm water is on the move, at least somewhat. It's not completely cloistered and sequestered here in the West Pacific. It's starting to shift off to the east a little bit. The 24-degree isotherm, nice and thick here at 140 west, and building to over to about 120 west. Still reasonably shallow here in the East Pacific, but you would not expect to see this to get really start building in depth here unless an El Nino were occurring. And what that means then is a lot of this warm water would be shifting off to the east. We do not expect an El Nino to happen, but just seeing this trend suggests that La Nina is either dying or dead, and that we're returning to a more normal pattern. And again, the previous charts where we saw the area of low pressure bias moving over the dateline, filling the Kelvin wave generation area, another sign that we're returning to a normal pattern. And that again is suggesting that by the time we get into this fall, the atmosphere will be coupled with the ocean, and that we should be in a much better position for storm development. Anyway, looking at anomalies, differences from normal this time of year, subsurface ocean temperatures. We've been watching this Kelvin wave continuing to push across the Pacific. Now not looking quite as strong, still plus 3-degree anomalies. So when we say Kelvin wave, what we're talking about is during a strong active phase of the MJO, you get westerly anomalies, westerly winds effectively blowing over the West Pacific. That takes the warm water, this warm water here, and starts pushing it not due east, but to depth, and then it sort of forms a pocket and works its way across the Pacific, just like this, and that's called a Kelvin wave. That's why we call this the Kelvin wave generation area, because that's where you get the west winds, and that's what starts the whole cycle off. The warm water starts moving off to the east. It eventually completely traverses the Pacific, erupting around the Galapagos or Ecuador, and forming a warm pocket of water at the ocean surface that then gets caught by the trades and then backfills across the equatorial Pacific. If that happens multiple times and the pattern is strong enough, you end up with El Nino. Here's another model of the same data. You can clearly see the Kelvin wave on this as of April 28th. We're really interested in seeing what the latest update is going to be. Probably should post tomorrow. We see supposedly the leading tip of this Kelvin wave starting to erupt on the ocean surface at 100 west. So that would be just west of the Galapagos. Galapagos are about over somewhere around here. We also see this little pocket, the last little remnants of La Nina, and this would be up along roughly Peru, something like that. We'll take a look here in just a second. Sea level anomaly data supports basically what we're seeing in the previous charts. This is from JSON-2 satellite. Strip out all the waves, strip out the wind swell, strip out the tides, and you see this bump, 5 centimeter positive bump on the ocean surface. There's the date line, that's the equator. There's Australia, New Guinea there, Philippines there. You get the idea. Anyway, so that's warm water at depth. Of course, expands a little bit. That would create a bump on the ocean surface. And that bump continues the whole way across the equatorial Pacific. There's the Galapagos right there. So that basically is just more confirmation that there's warm water traveling off to the east, and that is the Kelvin wave that we're monitoring. Equatorial upper ocean heat anomalies, upper 300 meters of the ocean surface. Back in August 2017, there's our cool pool. This is the East Pacific. This is the West Pacific here. Cool pool associated with La Nina. First little Kelvin wave pushed across December into January time frame. Weak Kelvin wave, but sort of cut the legs out of La Nina. Then we had the upwelling phase of the Kelvin wave cycle. You can see it running from west to east over time there. And now here in February, massive active phase of the MJO created another Kelvin wave. And you see it pushing off to the east. The interesting part, it appears that it kind of almost looks like it's dying, but it hasn't erupted to the surface. The interesting part will be, is this only going to create subsurface warming, or will it actually have an impact on the surface? Well, I mean, clearly it's cut out all the cool water that was associated with La Nina from the East Pacific, but we really want to see some sort of eruption on the ocean surface to just sort of put La Nina to bed for good. We're not seeing it yet, at least not in this data. So then we take a look here. This is actual satellite sea surface temperature anomaly data. Differences from normal for this time of year. We see, here's Peru. Yep, normal, upwelling, cooler. The blues are a little bit cooler than normal along Peru here. But immediately off the coast, we see light warming here off the coast. There's Central America warming there. There's the Galapagos. We see another pocket of warming, a little bit more pronounced warming there, and west of the Galapagos. This is what we think is the eruption point for the Kelvin wave subsurface. But we really want to see a stronger signal, and we're not seeing that. It's kind of disappointing. We're kind of hoping to see something but we would have expected to see it actually by today, and we haven't seen much more than what has been occurring. This is kind of the same picture we saw last week. This is the only thing that's really new here. We'll see. Give it another week. But the good news is there's no real cool waters anywhere near here anymore. You see the warm signal pretty much from the equator northward. Last little bit of cool anomalies right here. This is the remainder of La Nina. Now, the Nino 3.4 region starts at 120 west. This is the main area for monitoring El Nino. 5 degrees north and south of the equator from 120 west out to about 170 out here. So you see, still kind of cool, the hangover from La Nina, but all the underpinnings of something other than anything that really feeds La Nina is all but gone. The trend for the past 7 days is just a 7-day trend. You see right in this area, yeah, there's that little bit of warming, but the warming around the Galapagos is really kind of backed off, and there's little random pockets of cooling. Now, this doesn't mean cool water, it just means cooler compared to what it was 7 days ago. We're talking not a whole lot of cooling, but you sort of get the sense there's this pattern here of cooling developed. We really don't want to see that. If anything, we want to see warming in this area. So otherwise, broad area warming here, all out from the date line to about, even the green is neutral. So let's say the Nino 3.4 region is generally warming, but nothing dramatic. And then the backed off view. Here you go. The little finger of warming along Peru, not as pronounced as last week at all. Generalized warming around the Galapagos. And then here's your Nino 3.4 region right in here. Yeah, mixed bag of still cooling, a little bit of warming, but nothing significant. We want to see warming building in this area so that the trades can take it and backfill it into the Nino 3.4 region, pretty much wipe out this cooling. But we're not so certain that that's completely going to happen, at least not dramatically. It might be more of a very, very slow transition. Here's temperatures for the Nino 1.2 region, the area between the Galapagos and Ecuador down into Peru. And you see temperatures there still a little bit below normal. Today, we dropped off a little, 0.9 of a degree below normal, 0.923, but then trying to work its way up again. You see it's sort of, you could draw a line through this and see this very gradual warming trend. Nothing dramatic. We kind of want to see something dramatic, but I don't know that we're going to. And then the Nino 3.4 region, the trend was definitely upward till about 4 days ago, and now we've had this sort of backsliding. Today's value, not even a half degree below normal, 0.484. Still, we want to see it coming up. We'll see what that Kelvin wave does. Hopefully, it will nudge it towards the neutral range. So, what's the effect of the ocean temperatures in the Nino 3.4 region on the atmosphere above it? We look at the Southern Oscillation Index, difference in pressure between Tahiti and Darwin. Negative numbers suggest the active phase of the MJO. Well, we're down at minus 24.57, but you need multiple days of that, and you just sort of scan down here. Yeah, it's sort of a mixed bag. We don't see a trend yet. Certainly not clearly indicative of the active phase of the MJO, but negative numbers, any way you get them, are good. 30-day average, that smooths some of the noise out. You can see definitely the trend was we were up at 11.87 on April 13th. It's been downhill the whole way. We're down at minus 1.88, suggesting, well, at least not maybe the active phase of the MJO, but a dead neutral MJO pattern. Then the 90-day average SOI, you can use that for sort of looking La Nina, El Nino. We were up. You can see the trend, 5.71 positive 5.81, and then slowly going down. Today, 2.57. So basically dead neutral or neutral slightly biased towards La Nina because there is lingering cool water there in the Nino 3.4 region. The ESPI index, basically the same as the Southern Oscillation Index, but instead of looking at pressure, you look at precipitation anomalies, specifically in this area. Is there more precipitation or less precipitation than normal south of Hawaii, north of Tahiti, that sort of thing? If you have cooler water here, then of course you're going to have less evaporation and less precipitation. The index, about minus 0.4 below normal. Still meaning there's cool water in this area, and that's inhibiting precipitation. We want to see this go to 0, but we're a lot better than we were even a month ago when it was at 0.9 or 1.0. So slowly, the cool water is fading. Slowly, the ESPI index is returning to normal. We really want to see that Kelvin wave just completely obliterate the last of the cool water so this index can go to 0, and then we'll be at a normal neutral pattern. Then finally, the forecast from the CFS version 2 model. Sea surface temperatures, the Nino 3.4 region for Sunday, May 6th. You see as of, let's see, we're into almost May, so that'd put us about here. Supposedly just 0.2 of a degree below normal, going neutral by, that would be the 1st of June. That would mean La Nina officially dead, and then a slow creep upward through the summer into the fall, reaching half a degree above normal, which is about the exact opposite of where we were this past winter. So it would be neutral bias towards El Nino instead of neutral bias towards La Nina, where we were last winter. This would be more favorable for storm development and just in time for the fall-winter season. But so we'll see. The model's been doing pretty good. We'll see whether we actually get there. So for right now, 2 gales in the North Pacific Ocean, both generating swell, one targeting Hawaii, one targeting the U.S. west coast, and ample wind swell in the forecast as well. But more interest is on the storm corridor. First, a little gale south of California developing right now. That will produce swell pushing north about a week from now. And then beyond that, a series of storms forecast pushing under New Zealand, perhaps generating more favorably angled swell relative to California. But never believe a model a week out. But there's hope there. That's what we're looking for. And of course, the demise of La Nina is setting us up for a better season as we move into the fall. So that's it for this week. We'll do it again next week. Same time, same channel. Thanks for watching.